Hi everybody, hope you're all having a great day. Okay, I don't know what was happening there. OBS was not working or didn't capture Unity for a bit, but I think it's fixed now. Yeah. Alright, well anyway. Um I hope you all had a great long weekend. Mine was pretty good. I ended up having to do some work yesterday anyway, but that's alright. Now today, I don't know what it's like everywhere else, but the weather here in Texas has been really strange lately. Yesterday we had like record highs, and or not yesterday, last week, and now it's going to get like below freezing tonight. So I'm gonna have to just do a short stream today because I need to go take care of my plants and stuff outside. But yeah, let's go ahead and get to the programming. Okay, got to open another page. Alright, we'll have that loading well. Okay, so let's just go ahead and test the game and see what state it's in. I'm gonna build a second client that will connect to it'll just take a couple minutes. I think last time we were working on the ping detection system, which pretty much tells tries to estimate about how long it takes to send a message to the other client. And we need to know that so we can try to synchronize our actions as best as possible. And I realized I kept on calling stuff, I kept on calling it ping yesterday, our last stream, and ping is more specifically the actual message. So the term I should have used was latency, which is about how long it takes for a message to get to the other client. But not that it matters a whole lot. Yeah, so we're connected now, and we're sending the ping messages back and forth. So we can see the latency is about half the round trip time. And what it does, it sends a new ping every 3 seconds, and then it takes, I think, the last 3 round trip times and averages them together to get this average round trip time, which is what we'll use for calculations. Now it's interesting that they have different ones. Also, it seems like the client's round trip time, well, as I say that, it changes, but I was going to say it seems to be a bit more consistent. But anyway, we can also, I have movements set up, but it doesn't update on the other player, so that's what we're going to work on today. Now, this game is going to have what's called a peer-to-peer architecture instead of a client server. So pretty much each game is going to be, I guess, the sole controller for its player, and so this game will just be this blue player 1, and it will take care of collisions and have the control over the position of this player, and we'll basically just get everything about this player over the network. And we're gonna just have to trust it, because in real time with latency we can't really, well, I mean, we could have the first player act as the host, which would mean that this player would be the sole controller of both, and so all we would get would be input events from the second player. The problem with that is that I don't think it would feel too good to play as a second player, because we'd always be behind the server. That's usually how most multiplayer games work these days, because you want to have some central server that's the authority over everyone. And so that can work fine, but it is a little bit more complicated, and that's where you get some weird things like, I don't know, shots not registering, or you being hit with something when you didn't when it didn't actually look like you were. So we're going to try to minimize that with this game. And since it's peer-to-peer, it should work okay. Okay, so but we're still going to have to do what's called client-side prediction, except it'll be a little bit different here on the peer-to-peer because there's no real server. But basically, I guess this player will try to guess where this player would be when it receives an event. So, for example, it will receive an event that the player has started moving, but it'll be, I don't know, 35 milliseconds behind. So it will actually try to accelerate this slightly faster than normal so that it will try to catch up with its actual position on the client. And that's what's called the client-side prediction, and just so that you can try to minimize the difference between the two players on screen. Just because of this latency, and it's impossible to know exactly what time the other computer is at because you don't know exactly how long each message will take, and it's pretty complicated. But we're just going to take it a step at a time, and today I'm just going to send over the position every, I don't know, we'll figure out some time step maybe every second, and so the client will kind of just pop around like my pointer is right now. So it won't really look too good, but it'll be a good starting point. Forgot to commit this since the last stream. Maybe I'll just go ahead and do that real quick. Although I don't remember exactly what I did. Okay. Oh yeah, we just did ping pong, so that'll be stream 4. We just did ping messages, and then find average latency. Okay. So there we go. Now that I can just revert these files if I mess something up. Okay, so yeah, we got the player. So basically we need to start sending events out whenever something changes. So let's see. So I know I kind of started on this a little bit before, but that's not it. I think this, oh yeah, last network movement received. I think I'll just delete this because it was a little premature me trying to do that. Alright, so let's see. I guess we'll just want to, let's just do something really simple. Okay, I'll have a class that'll just be, I don't know, current player state sender. And it can like run at the very end of a frame, and so whenever it receives a message to send an event, it will send it, or we can even just have it send every couple of seconds as well. I think the combination of those two should work pretty well. So I want this to be a flow logic container because this superclass just allows me to use the network, or not network, event system in this game. And we'll have, let's see, the data sender helper. I keep meaning to rename this class because I never remember what it's called. And then we'll need the player state, which is, oops. The input state? I thought I had one. Oh, positions, yeah. Okay, and then we'll want to, in the final one, we'll want to send also the input But I guess I'll wait to do that. Let's actually change this to player position sender because it's not going to send like the player's health or anything like that. And then, yeah, I don't really need to have current at the beginning either, so let's just shorten this. All right. Okay, so I'll go ahead and get the input state here. I don't know if we'll send it over immediately, but I know I'll need it later. Because this input state is basically the velocity. Okay, and then... No, that's to receive. I was going to say there was some other class I needed to register a message receiver, but some other class will take care of receiving these events. Okay, so now I need to pass the event queue up to the parent class just because it needs it to set up everything. Okay, so let's see. Every update. Okay, let's just do something really simple right now and just send an event every few seconds. So private float, timer. Oh, we'll need the game state as well. Because this game state will tell us if we're paused, for example, or not even in the movement phase. Okay, I know I'm going to forget to set this up here, so I'll go ahead and do it. Okay, so if we're in the right phase, which would be movement, then we'll just subtract from the timer. Oops. Okay, I need to get the Unity namespace so I can grab that. And I guess I'll just set up a constant here, which will just be, I don't know, send period. Oh yeah, I have to actually set a value. Let's just do it every second. So if... Okay, I just did this backwards, so this will just be plus equals, that should be fine. So then we set the timer to 0, and then we'll just call this send message. Create an event. And let's see. Okay, so this is the fun part. We'll want to get, what's it called? Network writer. Oh, I can spell it. I don't know what was going on with my fingers there. And this is just a class that Unity provides that simplifies writing values into a byte array. Okay, so writer equals new. And then we'll need to pass the byte array, which is just the sender buffer. And so first we'll want to write 1 byte, which tells the type of message. So I guess this will just be player position. I'll need to go ahead and generate an enumeration member. Okay, so it inserts it in the right spot. And the game just uses that number there to tell what type of message it should expect. And then I guess next we'll just need to send the position. I wonder, does it have a vector 2 version of this? Okay, well, it has a quaternion, so I'm guessing it has a vector 2. Yeah, right there. So we can just write the position layers. Oh, we need to figure out what index we are. Let's see, int player index. And then if, let's see. Okay, so how did I figure out what player I am? I guess we'll need the network info for that because we'll need to know if we're the client or the server. Yeah, I wasn't sure if I wanted to make an easier way to do that. Let's... Okay, well, maybe in the final game I want to do that. But I want this to kind of just be really simple, so we'll just have a bunch of different references here in the constructor. Doesn't really matter. I'll just call that the net. It should be fine. Yeah, probably I could even have this data sender helper contain a function that would return the player. Maybe I'll do that. So public int get managed player index. Okay, so if info dot, I guess we should do a switch here. So switch info network type. Okay. This is a little confusing because we don't really, like I said, we have a peer-to-peer, but I guess one player kind of serves as a server because the other player connects to it. Maybe I want to change those. Because yeah, it's not really a server, but okay, and then if there's anything else, something's gone wrong, so I'll just want to return -1 to trigger some error. Let me see. I guess I'll just call this the hosting. And connecting. Yeah, so this one is the one that hosts the connection, and this one tries to connect to it. I mean, it's kind of just semantics, but I don't know. I always say naming is really important in programming so that you can try to keep track of everything. So now I can get this just from the sender, which is probably a simpler thing to do. So I don't need this net info after all. Okay, so I want to write the position. It has a velocity, but I don't know if I need... Maybe I should send it. But the velocity is kind of something that... Okay, well actually we won't change the maximum velocity. We'd change the acceleration to try to match the velocity. Okay, well, I don't know, but we're not going to use it now. We're just going to use the position. I was trying to decide if I wanted to send the player velocity or the input, but I guess it's really not that much different. Okay. So now we'll just need a receiver for this. Let me see. I guess it'll just be the player position receiver. Okay, so again, this is just so we can use the event system. Yeah, I guess we'll want the positions. Okay, so right now I'm just going to read in the position and then just set it here, but probably in the well, not even in the final game. I want to change this pretty quickly because we'll want to just use this or the received values as kind of a guide, because again we'll have to do that, the prediction, because we have to deal with latency and things like that. So what else do I need here? Okay, I guess I'll need the network info because I'm gonna need to. Well, let's actually data sender helper. We'll use this because we're not actually gonna send a message, but I'm gonna have another class here to get the okay, the other player index. But maybe okay, I should just create a different class that handles this, I think. Okay, let's just call this player index helper. Okay, we'll just be really specific. This will need the net info. Oh right, I need to change the namespace here so that it matches up. I know that there is a way to do it. I need to figure out the way to get this namespace to automatically be created with the correct values there. Okay, and then we just have this. And then I'll have another index or another function to get the remote player index. And this will work because we're only planning to support 2 players, so I don't have to worry about getting a list of remote players or anything. So I guess I'll get rid of this from here. And we'll get the player index helper. Okay, let's not try to get fancy with abbreviations. Okay, and so now I'm going to need this as well in the receiver. Okay. Oh, right, I need to pass the event queue up. That's what it's complaining about. And then I do need one other object to register our receiving function. Let me see. I forget what it was called. Okay, this is message handlers. Okay, so then we just add. Oh yeah, we have to do a safe set. Which again, this is just kind of a helper function that if the list is too small to set this value into this index, it will just extend the list to make it large enough. Okay. And the reason I did it this way instead of using an event is because it prevents us from having a lot of garbage. I guess one weird thing though is that I'm going to create a network reader right here, which is another object that would create garbage. So it kind of defeats the purpose, but I think you can reuse these. I'm not going to do or worry about it here because it just seems a little premature to try and optimize that out when we're still in the middle of programming this, but that's something to keep in mind for the final game. Or in the middle of just trying to figure out how it works, I should say. Okay, so first of all, we're just going to throw away the type because we don't need that. And then the next we just need to read the position, so vector2 the received position equals reader dot read vector2. Okay, and then we'll want to get the player index from the player index helper. Okay, so get the remote player index, then positions dot players index dot position equals the received position, and so then it should just update. One other thing I need to worry about is the order that this is called. So since this is not an event, this message or this function is just called immediately when we receive the message. Let me see when that is. Trying to look. What did I call it? Network test game. Okay. So the network message receiver has this priority. Okay, so it runs right here. So technically, it's also setting the position right here. I think that's probably okay. Actually, this receiver, or wait, the position receiver doesn't need to be a flow logic container because it's not listening to any events or even being updated. So I think I'll just do that. Because that makes it really obvious that it doesn't have a ticking order. Okay, so, but I do need to have the player position. Okay, and I spelled those differently, which is gonna annoy me. I think I'm gonna create a new ticking priority for this because I want it to run after that. Because all the physics and everything happens in here. Okay, and I'm gonna go ahead and rename this. And then it doesn't automatically rename the file, so I'll do that here. Okay, and then I just, instead of calling initialize, I would just call context resolve network message receiver. Again, it doesn't, I don't need to call the initialize because it doesn't have a ticking priority, so that works fine. Okay, so that should be all we have to do to get the players to kind of move around, although it will be pretty not smooth. Okay, so let's see, no object. Oh, I need to create that player index helper. So context, resolve and bind, player index helper. Okay, it is running. And no errors, so I think we'll be fine building the second client and testing it out. get rid of this. Oh, it's still compiling. There we go. Okay, so we'll start server here, and then start client. Okay, so it should be sending messages. I don't see any errors so far. Did that update? No. Okay, so it doesn't seem to be sending any messages. Let's see. So, ping display. Oh, I didn't. Okay, this was a silly mistake on my part. On the map position sender, I just write the message but don't actually send it. So let's see. Send to other player. Again, this will be unreliable because if we miss a message, that's okay. We'll just send it again next time. Positions, players. Oh, that's not right. We want to. The length of this message is what's written in the writer, so. Position. Okay, so yeah, now I need to build it again. Alright. Compile again for some reason. Okay, so are there any errors? It looks fine. So let's. Okay, now there's an error. Unhandled message. Did I do something wrong? Because I thought. Then to other player. Let's see. Rid of that. This unhandled message has a type here. But didn't I register it in the message receiver? Player position receiver. Safe set the player position, and that is 3. So did this not? What happened? Let me look here. Oh, I resolved another network message receiver. It should be player position receiver. Okay, just a typo. Let's just build it again. This is the only bad thing about making a multiplayer game in Unity is that you have to compile a second player before. I mean, yeah, but every time you want to try and test it. Okay, it complained because it was still compiling. And again, I think I told this last stream, but if you are doing this, be sure that you set the scripting backend for your project to mono instead of the C++, because it takes much longer for the C++ to compile. So once you're done with your game and you're not having to test it so much, you can switch to the faster C++. Yeah, right here, the scripting backend. I want to keep it on mono. All right. Okay, let's turn messages back on. Okay, so now, okay, now we can see it update. But yeah, it's lagging behind. Don't even ignoring the fact that it jumps every second, you can kind of tell that by the time the message gets to the other player, it's behind where we are. So like, if you look really closely, you can see, and that's just because of the latency. That would be what we'd have to try to fix. Let's try it the other way around. Unfortunately, we can't really check it in real time, but we should see blue should be over here. Okay, so yeah, that does work. But at least we've kind of gotten positions set up. Okay, so what if I did something like really simple where we just sent over the input and then just had the player keep on moving in a straight line from the input every time we receive the event. That would at least get it a little smoother, but it will still be jumpy, especially on turns. And again, it still won't match up, but I think I kind of want to just take this one step at a time because this is going to be a complicated project. All right, so in order to do that, we don't want to just deposit the player's position right when we receive it. We'll want to have some other class that we store these messages. Okay, let's just call it, I don't know, remote position history or something like that. Because I'm trying to think, will we ever want to keep multiple, like more than just the latest? Well, let's just do remote player history. And I guess we'll prepare in case we ever do want to have more than just the current. So we'll have public vector2 position, and then public vector2 input. Do I want to do input? I keep on going back and forth, and if I want to do input or velocity. I think probably input because, like I said, the velocity... Well, I guess the velocity doesn't change, it's more like the... Oops, my webcam just knocked. Okay, hopefully it'll stay put. Yeah, the velocity... The max velocity won't change, it'll be more like we'll mess with the acceleration to try to get the velocities to match up. I don't know, I think we'll just have to play with it. Let's see, okay. But regardless, I'll just go ahead and write the input here. Okay, and that is a vector2. So then the receiver will also grab that out. Okay, so we'll change this class a lot. We won't really need the positions anymore. We'll just want the remote player history. And we actually won't need the index helper anymore either. Okay, and probably one other thing I want to have is like the frame this has been updated. So int update frame. We can get rid of that. And I guess, yeah, I don't even need to store these in temporary variables. So history dot position and history dot input, and then the update frame will just be time frame count. That way some other class down the line can see if it's changed this frame, and in that case we'll want to also change some information about the player. Okay, so I have the local player mover, don't I? Is that what I called it? Yeah, local player mover. So I guess I'll just make a remote player mover. I have a feeling we might need to separate this into multiple classes because this is probably going to be more complicated than the local player. Okay, so this will be a flow logic container, and also it needs to be in the right namespace. So we'll want, okay, what did I call it? Ping results, because we'll want to know the latency. Although I don't know if we'll need it. Yeah, we won't actually want it now. We'll want it down the line, but right now we're just doing a kind of naive algorithm just to test it out. This will be history, and then we will need the positions. And then private player index helper. And the game state. Do I need... Oh yeah, I need the game constants because I need to know like max speed. So. Let's shorten that line a bit. And I have to also send the event queue. Okay, so every frame will look to see if history dot update frame equals this frame. Then we'll want to reset the information in the positions. Okay, so first we'll need to get the other... Okay, well, one other thing I should do is if state phase equals movement, then we'll, I don't know, I guess update position. I'll move this into the other function. Gonna get rid of some of the indentions in there. Okay, so if this is the case, well, I guess we'll need the player index. Or actually, we should just get the player object. Okay, that's fine. And then we'll set player dot position to history position and player dot velocity to history dot input times the max speed. So we won't do any acceleration or anything at the moment. And then if the history has not been updated at this point, then we'll just set player dot, we'll just linearly move it by the velocity. So time, delta time. Okay, so let's just go ahead and add this player or this class to the game system. Guess I'll just put it on the normal phase. When is the local player? Okay. We should probably have like a separate physics phase. And actually, shouldn't the class... Okay, does this class measure the ping? Yeah, also, this doesn't need to be a flow logic container because it doesn't have an update. Yeah, because I was thinking that whenever the ping gets updated, that should happen before we actually do other things, because the latency will be needed at the beginning of the frame. Let's see. Again, we could just resolve that class instead of doing that, and then I'm trying to see what's the class that actually updates. Oh, hey, Wonderful, thanks for the host. How are you doing today? I hope you had a great stream. Okay, so the Cinder does have an update. I'm trying to look for the class that receives the Pong messages. Okay, it's right here. Okay, this doesn't need to be a flow logic container either. Actually, well, no, it doesn't. But it just wants to grab the events, so I can just store my own reference. Okay, got some results after a few steps back. Yeah, I know how that is. Kind of experienced that a couple streams ago, working on this networking. Okay, so got this lowercase e there. I don't really need to do this, but I think it's kind of helping me just clean up this update queue or update list so that I don't have junk items in there. So this happens just at the same time as the network message receiver. Okay, so that's when the latency numbers are updated. So that is at the beginning of the frame. Okay, so I think we're fine right now, although I might want to have a separate physics priority so that the physics works before other classes. I don't know, we'll play it by ear. Okay. I'm just going to play the game like this just to make sure that there's no silly errors before I waste time building the other player. It does look like I forgot something. Oh yeah, I need to add the remote player history into the context here. Alright, so hopefully we can at least get this working. I need to sign off pretty quickly here because like I said, I have to go cover my poor plants before they're frozen to death. Let's go. Okay, well there was no errors that time, so I guess I can build the second player now. Alright, okay, still compiling or cleaning up. Started this server and the client. Alright, so let's see what it looks like. Oh, it's still measuring latency. You have to wait a bit. Okay. Well, it's a little better because it doesn't just jump around quite as much. If you move in a straight line, it's actually pretty good. But yeah, whenever you have curve or the acceleration changes, that's when you get to the problem. So I think the next step here would be to actually send... Let me see. We'd send, like, whenever the input state changes, we'd send an event at that point. And then we would want to simulate the actual acceleration changes. And so we'd get a pretty smooth player movement over here. I think the issue would be that it still is going to be running behind because of latency. So we'll have to do that client-side protection I was talking about, or client-side prediction I was talking about earlier, where we actually speed up the object over here so that it matches what's on the managing client. But yeah, that's step or two away, I think. But yeah, I'm glad that we at least got the messages sent through, and I mean it doesn't look good, but at least it's kind of functional now. Let's see, make sure that it works the other way around, even though we can't watch it in real time. Okay, so it is in the right spot. Alright, well unfortunately I think I better call it now because I do need to go take care of my plants. And I guess hopefully I won't freeze overnight, but no, we'll be fine. It's just so weird it never gets this cold in November, but I guess that's the weather for you. But yeah, I hope you all have a great day. I'm planning to come back tomorrow and we'll try to smooth out this movement a little more. Maybe we'll get to the client-side prediction. So yeah, feel free to follow me here on Twitch if you want to be notified when I go live. It should be around noon Eastern. I also have a Twitter where I always post when I go live if you'd rather see there. And then I have a YouTube channel where I post all videos usually about a day after the stream if you want to catch up or you're just not able to make it. Oh yeah, and then I have a Discord server if you'd like to chat with me. I try to stay on there most of the day, so I'd love to have you. And an Instagram where I post development screenshots from my other projects. That's pretty new, so yeah, if you're interested in any of that, I'll have links in chat. Either way, I hope you all have a great day, and I'll see you tomorrow. Bye-bye.